thanks for coming. Appreciate it. Hi. So I'm Chris. So I work in the QA practice of ECS. Thanks for coming. Hope the food is good. I'm going to talk to you. Oh, and we've also got Vipul, who's somewhere, but Vipul's also on this project as well. So for the past year and a bit, I've been at Channel 4, and I recently rolled off. And the challenge at Channel 4 was testing their application on a set-top box. So I'm going to talk about what myself and other people on the team did to meet that challenge. So this is just the agenda. So we're going to define the problem, at a very high level what the solution was. This solution also involved a bit of thinking about the hardware as well. So what hardware did we purchase and why? How our solution works. We'll also go into a little bit of the programming side and talk about the models, the pros and cons of our solution, and then what the future possibilities this poses for us. So. Channel 4 have an app. It's called the All 4 app. You can go and download this off the marketplace right now. Some of you may be using it to watch Hollyoaks and other stuff. But the challenge that we faced is that they wanted to test releases on this app in an automated way. So the manual testing practice that they have at Channel 4 is quite extensive, but they're also looking at how to automate it as well. So you can think about the kind of platforms that these guys are releasing on. So it runs on an Amazon Fire TV stick, Roku, Freeview Play, and a whole bunch of other stuff, Samsung TV. So you can imagine how laborious it can be to test on all these devices every time a release is produced. So what we wanted to do is figure out how can we automate this process. The app is written in HTML5 and JS. For those of you who are unfamiliar with the set-top box market, but that is the general direction that most IPTV apps are moving into, trying to make things web-based and standardized in that way. The problem, however, is that even though it's essentially a web app with a JavaScript face, most set-top boxes give you no access to the DOM at all. So it's not like, so it has its own native browser, but there's no real way of accessing the DOM. There are some devices where that's possible, but most of them don't. So you can't really use something like Selenium to test on a physical device. If you have a browser-based version of your app in-house, you can test on that, but it's not the same as testing on an actual real-world device. So how do we test it? And the quote there it may be a bit small, but the set-top box market will be worth over 46 billion by 2027. More people are watching TV through IPTV, through Netflix, than they are using regular terrestrial TV. People want on-demand TV. That's not really a new demand, but the volume at which this is happening is growing rapidly. And also, every TV channel that's major around the world is looking to build their own application that can run on these devices, and Channel 4 is one of the early adopters of it. So, at a high level, what we opted for was to use image processing to test the application. So what we looked at is how we can use, so we developed a Python solution, and we used a well-known image library called OpenCV. You can get that on a range of programming languages, and it's basically image processing. So a lot of major research is done using OpenCV. So we use the goodness in this library to basically perform image processing. We also used optical character recognition. So we're not too familiar on the guts of how it works because it's produced by Google, and we used a library called Tesseract OCR. And what it's basically doing is that we take images of the screen with text in it, and this library will try and interpret it into natural language. And it's got relatively good accuracy. Most of the time it's working 90, 95%, 99% of the time. That's the tolerances we're looking at. Python, OpenCV, and Tesseract. And because we do QA, we're also doing it in a BDD way, which I'll show. And as I said, there's no way of accessing the DOM. So when we test it, we'll go into the hardware setup. Now, unfortunately, we had some technical issues, so I can't do a proper demo, but I can show you kind of how it works. So when you can't access the DOM, the way that we had to access the screen is by using screenshots. So what we needed to do was transmit the output of a set-top box, which is HDMI, usually 1080p or higher, and we captured that into a video recording device, which is somewhere around here. Yeah, there it is. And we output that to our machine. And then using regular Python functions, we can take screenshots of what's going on, and that will be the image that we perform our processing on. So the way it works is that you have your dev machine with the code running on it. It goes to a screen recorder. You plug your set-top box into the screen recorder rather than plugging it directly into the TV. And you're basically funneling the signal back to your dev machine. And then your TV effectively acts as a secondary monitor. And that's what we use to take our screenshots off of. In the case of Channel 4, and most likely other channels as well, they also have a feed service where all your contents, from the programs themselves to images to subtitle text and other metadata, is accessed through an API. So what we were able to do is we can also access that data into our testing environment and compare what we see on the screen with images from the feed as well. And that adds a bit of a dynamic nature to it. We can also test static images as well. So we have the option of both. But the idea is, you can imagine, with new releases, new shows, your home page or your channel page is changing all the time. So if you take a screenshot today, most likely that's going to change tomorrow. So by using the feed, we're able to keep our test dynamic. So this is a very high level of how it works. I don't know if the glare of the screen obscures it, but I'll try and explain it. So we initialize the application, i.e. just going to the home page. We perform an action of some kind. Now, on devices like Amazon and Roku, you can control these devices through an API, through just sending API calls. In fact, that's how, for those of you who have Amazon TV, that's pretty much how your remote control works. It's sending commands to the router rather than an infrared signal. So by performing that action, you're, I don't know, moving left, moving right, selecting a show, whatever it is. You then take a screenshot of what it's supposed to be like, and then you verify that screenshot. And this can be done either from a static image that you've pre-recorded and it's sitting in your framework, or you can get it from a feed. And then once you've done that, once you've verified that you are where you are supposed to be, you can then go and perform another action and do the same thing all over again for the sake of your tests. So a typical test that we would run is verify that I can watch a particular asset. So you can think about the actions involved in that. Initialize the home page, search for the assets, go to that brand page, and then select your episode, and then verify you can watch it. And all of these steps involve screenshots, moving around the screen, taking more screenshots, and then comparing. And in some cases, some text recognition as well. So we tried to make our solution to be platform independent to meet what Channel 4 is trying to do, which is to test on multiple devices. So we basically adopted the page object model, and I'll go into the code as to how this works essentially, but we have a model class, and that model class will contain our generic actions. So like pressing a key, taking a screenshot, verifying some text on the screen, that sort of thing. Then for each page, we then have a page that inherits from the model class, and that will do more specific things like go to the home screen or select an asset or something like that, which make use of the methods from the superclass. And then when it comes to the different platforms, so Amazon or Roku, we will then, if it's needed, we will then perform further methods in there that are specific to that platform and that platform only. So for example, some devices, the homepage looks quite different to what it would look like on another device. So go to homepage can't be reused in that respect. We have to come up with a platform specific method for that device in order for it to work. And that's kind of the structure that we go to. And we like doing it this way, because you can imagine if we have a new device, for example, the PlayStation 4, we can just add a new PlayStation 4 class that inherits from home or whatever page, that then inherits from the model, and make use of the code that we've already written. The pros and cons of our solution. So first of all, we can test outside of the DOM. That was pretty much the biggest challenge that we managed to get around. And we can test on a physical device. So before this, we did look at ways that we can test in the browser, and it worked fine. You could open up Selenium as you might do and run it that way. But in order to test on a physical device, we simply couldn't use that option. So that's why we opted for this, and it's worked pretty well. We think we've developed a platform-independent solution. So far, we got it working on Roku and Amazon, but we, depending on how the project goes, I'm no longer on the project, so it's really down to Vipul and his team now, but we could expand into the PlayStation 4, the Xbox One, and other devices as well. And essentially, it's a Python application, so we can introduce new drivers, new code to control different types of devices. So for Amazon, it runs using ADB. So we introduced an ADB library, and when it comes to the key presses, it simply calls in the ADB commands. But then if we changed and went to Roku, it will then look into the config file for the Roku commands and then run those Roku API calls instead. And you can imagine that would be the same for other devices. For remote control devices like Freeview Play, that's where it can be a bit more tricky because you introduce a new layer of hardware, which is essentially an an infrared transmitter. So you would need to plug that into your machine, but essentially it's the same sort of maintainability where you can just add new commands to process remote control key presses for that particular device. You just need to make sure that it's pointed at the physical device itself. And this, I guess the reason why I chose to present this is because it adds a different kind of testing paradigm. When we worked with people who aren't technical, who are managers, but they're not really technically minded, and their honest opinion of it is that they don't really mind, that it's not that meaningful to them that a tag appears and it's got the right kind of text on it. What they found more useful was that the image is showing that that tag, which represents some data, is presented correctly. So it's got the right font, the right color, it's in the right part of the screen, that it's presented in the right way it should be. And so even though it is a bit of a hacky solution, and it's quite a new solution, they did prefer that form of testing over regular element inspection that you would do. So that's kind of some of the feedback that we got from testing on, in this way. The cons. Image processing is essentially matrix analysis. You're doing matrix maths on image files. That can be a slow process. So we did find there were performance issues when you're doing extensive tests. So occasionally, when you have to put wait periods inside your test to make sure that you're giving OpenCV enough time to process images. So in some cases, it's actually faster to do it manually than it is to do it in an automated way. The benefit that this provides is that, so the way that we worked in Channel 4 is that we took care of some of the devices and then freed up the time for manual testers to then go and test other things as well. So one of the improvements I would make is how can we make it faster? How can we perform the image analysis in a quicker way? Image accuracy issues on small regions. So there were occasions where you had to deal with small thumbnail images, and also overlay images. Like for example, if you're watching a program that has a guidance rating, it will have a little G in the corner. And verifying that that G is present can be tricky when you're dealing on such a small scale. So there were performance issues in that way. So trying to improve the accuracy there was a challenge, and also for the optical character recognition. With OCR in particular, training the data to make sure it recognizes the fonts and that the text is what it's supposed to be is an issue. So there's elements of AI there which was outside the scope of our project, that we had to try and train the data to make sure it could do optical character recognition properly. And it's dependent on external hardware. Which means there's a cost involved, and also it means just there's yet another room for error in terms of what could fail. So we've been trying our best to try and reduce the amount of hardware we need. So the fact that we can use APIs to command certain boxes is a plus, because we can take out infrared transmitters. Right, so we weren't able to get the demo working, I'm afraid. We had some issues with connecting the box to the Wi-Fi, but what we can do is we can go into the code a little bit, which I'm going to show. So,
hang on, Chris, you've got a question, if that's all right?
Yeah, go ahead.
How could we improve the not so good things about the solution? If you go back to the slide before.
Yep.
You said it can be slow.
Yep.
something to fix long-term, medium-term?
Could you just repeat the question for a second?
Sure. So the question is, how can we improve the system? If I've understood it properly, how can we improve the application in terms of making it faster for its performance issues? So, in my opinion, there are some hardware things you can do. Just get a better machine that can perform the algorithm faster. What we've also tried to do is reduce the amount of data that we're processing at any one time. So rather than processing the entire screen, we get screenshots of a region, which we'll show. And that way you're performing your algorithm on a smaller set of pixels. That's another way. One of the things I would like to do in the future is research into different types of image recognition algorithms. So we kind of picked what works, but I would like to go into perhaps picking an image algorithm that doesn't regard color, for example, so just a black and white image. Things like that make the process a bit faster. You can do other things as well. So for example, if you edge detect your images, then that way you can only deal with the lines involved, which I have seen. So those are some of the things I would achieve.
So when you were doing, you captured the image and then you run the algorithm on it, was that all done on local hardware?
Yes.
So have you ever considered using cloud for something like this?
We did. We found that Google, for example, have an image recognition service that you can use, but they charge you for it. And basically, we couldn't justify the cost of doing that. But there are services out there. One thing to note as well is that the video recorder that we used was an option that we used because it cost like 100 quid. When I joined the project previously, they were using a much better system, which is made specifically for testing. I think the people at UView first developed it, and it works fine. The problem is that it cost about £5,000, which is a lot of money, and I couldn't justify the cost of scaling that for several developers to our project managers as well. Had we had the budget, we probably would have gone for that option. So there is something to say about using service-based image recognition software as well.
If long-term we get the budget to use it, would it easily be interesting?
I think it would be a lot more accurate, and I think it would be quicker because you're not that device performs the image recognition on its own hardware rather than on your dev machine. So yeah, you can get it, and you can also get the same thing that can manage multiple devices at the same time as well. But yeah, it's just quite a high cost to get it. Any other questions? Cool.
How many images are we talking about?
How many images? For a given test, okay, so you're probably looking about 1, 2. For a given test, you're probably looking at around 20 images. And also, some of the algorithms that we do, for example, in Selenium, you've heard of a wait period or wait until you see an element. We developed our own method, which is a wait until you see an image. So you can imagine how intensive that can be because you're constantly scanning for an image, and then as soon as it turns up, then you can move on. So we don't like doing that, but it is a good way of waiting for something to turn up. So what could be as simple as waiting for a home page to appear could involve several other image analysis to check whether or not you're actually there in the first place. And that's why it's kind of slow, because if a manual tester does it, they can just see that it's loaded up. They don't have to do that constant checking all the time. They just wait, and then when it appears, it appears. But for the code, you have to kind of bake that into your method, essentially. So your average an average test run, which involved about, how many feature files do you reckon, Vipul?
I think there's about 150 tests.
150? It took us about 45 minutes, right? Yeah, roughly that. So that's how long it would take us in general. Right. So unfortunately I couldn't show you a demo, but let me just give you a quick rundown of the code. So we used Python Behave, which is a BDD library in Python, and this is how we structured it. So you have your feature file. So for example, given I have started watching a brand asset, when I stop the asset in the middle of watching, then I should see my for watching populated with that asset. So basically in Channel 4, in the All4 app, when you watch an asset, when you stop it, and then in your account, in your My4 account, they have a section called Watching, which is basically things you can watch and then pick up from where you've left off. This tests that you can see the asset that you just broke out of in that library for you to watch later. So there's your feature file. In your step definition, what we're doing here is that we're getting a get menu model. So this is a model that is specific to that page, the menu page. So if we go to our models, and I'm going to find the menu one, which is here. What we've got here is the menu model, and then we've got two other classes, which is the Roku menu model and the Amazon menu model. So if we look at, say, the menu model, it's inheriting from our model class, which contains more generic methods. And in here, you've got a whole collection of methods to do with the menu model. So for example, open the menu, select a menu item, wait for a menu to appear, and so on and so forth. So these are, as the automation testers were developing tests, anything that we think belongs in the menu model, we'd say, okay, we need a test to do this. This is where we write it. And then, for a given platform, Amazon Fire, for example, you can tell that there's not a lot going on here. That's because most of it's been abstracted up to the superclass. But what we then do here is, for this specific test, someone felt the need to write a method here saying refresh view, which in this case is just pressing the OK button. And then for the Roku menu model, there's something a bit more specific in there as well. What we tend to use the platform-specific models for is for regions. So let me see if I can fish one up. Here we go. So one of the things that we try to do is take regions of a screenshot to avoid processing the entire screen. Not only is it less processor intensive, but it's also more accurate as well, because you're just testing the one thing that you're looking for. So when it comes to the platform specific models, what we put in here is the regions of the screen, and these are pixel values that we're looking at. So get me a screenshot within this particular region, and we're going to use and return that back to the rest of the program, and that's what you're performing your image analysis on. And so that's kind of the general flow. And what I'll do is that if I show you the overall model class as well, so this is kind of the highest you can go up the class tree. Here you've got very generic methods that are used throughout the program. So for example, getting the image path, performing a key press, that sort of thing. Checking if an image is on a screen. These are things that are used throughout, regardless of which platform you're on, and it can be reused. And I can't show you the feed stuff because there is some client-specific data in there, but what I can show you is our static image library. Let me see if I can find it. Here it is. So one of the things I mentioned is that you can take static images and compare it on the screen. So if we have a look at, say, Amazon Fire, typically that would be a static image. So how do I know I'm on the box set screen? So go to box sets, get me the box sets region, and check if it's equal to that. Check if what we're seeing on the screen goes above the image recognition threshold of what we can see here. And if you get a match of, say, 90% or more, I think that's the threshold, then we consider that to be a match, and we're on the right screen, and then we continue with the rest of the test. And that's generally how the static one works. But you can imagine this coming from a feed instead, rather than being on your machine. So we call an image from a feed, and we then perform the same thing and check that we're on the right screen as well.
So Chris, when you say feed,
so Channel 4 Services, they basically have an entire team dedicated to making sure that all of its content is accessed through an API. So that way you can use that for multiple platforms apart from the All4. So All4 Web, the iOS app, the Android app, and so forth. So we had access to their services feed, and we just call we make various API calls to that feed to say, get me, for example, this brand image. And then we get the brand image, resize it to what we want it to be on our own local machine, and then we do the comparison that way. So, and that's a key thing, because a lot of applications these days have their content populated through an API. And in order to keep things dynamic, that's kind of the way to go. And then what I also wanted to show you is just a typical results output that we made. So what you're seeing here is when we run a test through the BDD, we wanted to make sure that we could capture the results in a way that we can see what's going on. And so you can see here, these are basically step definitions. And so I select home in the side menu. It's got some wait images here. So these are images that it waited for. So if I open up this one, it may take a while. But this, you can see this is basically a loading screen. So what it was doing is that it was waiting for the home page to appear. It does that in certain intervals, and it took a screenshot at that time, and this is what it saw. So obviously that doesn't match what it's expecting to see. So it just carried on again, and it waited. And then the next time, it basically found what it's looking for and it moved on. And then if we...
You actually look for parts of the image in your full view, don't you?
Yes.
So you got like a little home thing,
yes.
Home the whole image?
Yes, for static ones, yes, because in something like the home, almost all of it is dynamic. The only thing that's not dynamic is just basically that little home thing. Yeah. But we know that it's constant, and we know that it guarantees that we're definitely in the right place, so we can look there. But then if we were doing, say, a home menu test, where we're making sure that all the, they call them slices, but all the right feeds are showing in the right place, we would check we're on home. Then we would then look at a particular region on the screen where we're expecting to see an asset, and then check that we'd call the asset to then make sure that it matches. So for example, one of Channel 4's biggest shows is Bake Off, which some of you may know of. Bake Off is a massive program for them. And when the homepage got populated at that time, we would see Bake Off stuff everywhere, you know. All the different episodes, mini episodes about Bake Off would also be there as well. So what we would typically do is, we know we're expecting an asset in, say, I don't know, this region of the screen. We'll take a screenshot there, we'll call the feed, and we would get back a Bake Off thumbnail. Does that thumbnail match what's on the screen? If yes, the test has passed. If it's failed, then that would get logged and we say, okay, there's a problem here. And that's kind of the way it works. So if we go
about data as well. So I think you're talking about running your test in production environments.
Yep.
Is that what happens?
Yep.
You have, like, no environment data?
No, we do not have any environment data as well. That's not to say you can't in the future, but we didn't feel the need to. The reason being is because it's coming from the feed and it's coming from the screen. So the only environment data that we had was account logging information. So logging into the All4 app. That's pretty much the extent of our data. When we were with other testing teams on Channel 4, they were kind of surprised to see that, and they did ask us a lot, why don't you have any test data? But the answer is just, we don't need it. It's really more about user acceptance and checking that we're in the right place. And other departments were responsible for things like feed testing and things like that anyway. This is a typical results image library that we produced. So for example, this is a screenshot that was taken, and this is what we saw on the screen at that time. So you can see we've got, this is the watching section, and under watching, someone watched Homeland. We then came out of Homeland and made sure that in the watching section you can see Homeland in the library. So then you could potentially go back to that and watch it later on.
Just one more question.
Yeah, go for it.
So you're saying you like start watching something and it goes into your My Watching list, and how would you reset that sort of state?
So the app gives you the ability to clear out your watching section if you wanted to. So what we did is at the end of it you can go into the history section and just clear all history, and you can do it that way. Depending on the test, we may even leave it there, and in the next step we go back to the asset, fast forward to the end, let it cook for about 5 seconds, and then when you go back to watching, it's gone because the app thinks that you finished watching that particular brand. That's not always the easiest thing to do. One of the issues that we had with an IP-based app is lags with, say, the connection, you know, waiting for things to load, and sometimes, even though you've sent an API command, it wouldn't get processed straight away. So there were some tolerances there as well. Now what I'm trying to do is see if I can find, here it is. So this is a more sort of log-based way of looking at the results, and what you can see here is the exact order of events in the way things happen, including key presses. In this case, we can see a match result was made here, and the result was 1, and that was based on a text match that was happened here. So what happened is that we used Tesseract OCR to look at a region on the screen. It found damned, or rather it found an image with some pixels in it. We ran the Tesseract and it came up with damned from its OCR, and then we verified that with what we should see from the feed, and we got the same result, and that was considered to be a match. And that's what we found in the end. So yeah, that's basically it. So in terms of the future, how I see this playing out is, one, set-top box testing can still continue to run like this, and if there is a case where you still can't access the DOM, this is a solution you could possibly think about implementing if there's a need for it. The other way I can see this working is that, given that there are some people out there that value image-based tests over, HTML-based testing, there's no reason why we can't take the same philosophy and apply this to other systems. A web app, mobile apps. In my opinion, if we can get it to run fast enough, games as well. So the games market currently right now is pretty much manual, to manually test games, which is great for teenagers on a summer job, but it's, why can't we do it in an automated fashion, where you just make an input to do something with a character, take a screenshot or a video feed, and then verify that with something that you expect to see. But obviously there's a lot of research that's required to progress into that market later on. Yeah, so that's the end of it. Happy to take any further questions. Thank you.
Could your tests run concurrently to increase to decrease the execution time?
So the question is, can our tests run concurrently to decrease the execution time? Yes, although I didn't have enough time to move into that just yet. So one of the things that we're trying to do now is to integrate this into continuous integration, where we can have a Jenkins job running multiple hardware, either for a Docker container or whatever type of machine you want to use, and you could have one container for one device running it on multiple screens, if you will, and you could do it that way. So yeah, I think it could be done concurrently in that way. Great. Well, thank you very much for your time. Appreciate it.